High-profile fires like the one at Lakanal House in Camberwell in 2009 re-emphasised the fundamental importance of reliable fire safety measures. In the aftermath of such events, many commentators call for more stringent fire regulations. Some call for interventions like compulsory sprinklers, while others argue for more thoroughgoing risk assessment procedures. All have their place, but the issue of passive fire protection is seldom lobbied for. Passive fire protection is the underlying design solution, rather than the technical fix, but it's often poorly understood. Here to discuss fire safety with us is Wilf Butcher, Chief Executive of the Association for Specialist Fire Protection. Well, welcome, Wilf. Thanks for coming into the studio. And what we want to do is take a look at some of the principles, the problems, and then the solutions. So let's first of all get an understanding of what passive fire protection means.
Well, passive as in the opposite to active, really. You know, we think of active, we recognise sprinkler systems or alarm systems, etc.
What I referred to as the technical fix.
Yeah, whereas passive fire protection is the fabric of the building. It can be the structural support of the building, or it can be the containment in terms of compartmentation within the building.
OK, so we're talking about compartmentation then. So essentially it's where the fire is kept in one section by a fire-resisting structure. What are the principles behind this compartmentation?
Well, in essence, the principles are three, we can say: stability, integrity and insulation. In this case, fire insulation. So we're talking about stability, the means of the building to be held up through the structure of the building, the steel frame or the concrete. The integrity, in other words, the avoidance of openings within the compartmentation. Or the fire insulation, here we're talking about the maintenance of a level of temperature in one room not getting to another room, so there's a safe evacuation.
And this, of course, protects not just the occupants, but also the firefighters, doesn't it?
Indeed. I mean, building regulations are there for life safety. They're there to ensure that people within the building can be got out safely and the firemen can do their job. It is not designed to be there to ensure that the building stays up forever. That's the job of the designer and the insurance company to decide, really.
Right. Now, I know that it's complicated, but are there sort of rules of thumb that we could look at for compartmentation locations, or at least something that designers should be alert to?
Indeed. I mean, the key things here is specifying the right kind of product to do the right kind of job. Generically, there are a lot of passive fire protection systems in the marketplace. They all have their place. The key here is determining which is the appropriate product to use in a particular circumstance, and not to mix and match.
Mm-hmm. Well, effectively, there mustn't be any breaches of a compartment's fire stopping, but that's what we'll come on to now. So, penetrations, services or structures that run through the building, they've got the potential to actually shortcut the compartmentation walls, haven't they? Presumably this is one of the most common breaches, isn't it? Because all buildings have got to have places for services to go through.
Well, the most common breach, of course, is the fire door. Humans are the most common breach, walking in and out of a building, which means that, you know, if you look around you in your office and see how many doors are held open with a purpose-made chuck, for example, that is a breach of the compartmentation. But otherwise, it is penetration. So it's everything that goes to make the building: piping, cabling, air ducting systems. They all have to pass through compartment walls. And it is the protection of those elements at that junction that's absolutely vital to passive fire protection containment.
And we're not necessarily just talking about fire spreading from one compartment to another, are we? We're talking about fire spreading quite a long way.
Yes, indeed. And we're also talking about smoke spread as well. In fact, smoke is more likely to kill people than fire is. Smoke can get through a hole as small as the width of a pencil and into a compartment the other side in less than 4 minutes. And
presumably also adjoining properties can be affected by this if the compartments are being compromised and the external compartments are being compromised.
Indeed. I mean, if you consider a recent fire at Peckham, for example, which was a timber frame construction building in the process of construction, when that building caught fire, the radiant heat from that was so intense that it actually impinged on the buildings close by it, and effectively there was mass evacuation to that building as well.
Yes. I referred to the Lakanal House tragedy in Camberwell. Do you have any thoughts on the likely causes of that?
It's an interesting one, this. I mean, the report into the fire at Lakanal House is still outstanding and will continue to be so for some months to come, I think, until we eventually see the inquest. But the Association for Specialist Fire Protection some years ago, along with some industry associates, the Passive Fire Protection Federation, BRE, carried out a quite detailed study, Partners in Innovation project, working with the government. Well, that identified a number of crucial aspects in terms of buildings of a certain age. In this case, it was more than 2 years of age, looking at what happens to the passive fire protection measures within those buildings after a given period of time, through either damage or following trades later on coming in and making fresh holes, and not, in fact, protecting those holes back again as they should do. So consequently, there's quite likely to be a high element of that, we think, with Lakanal House.
Well, let's explore now how we can fire stop around these penetrations, and can you talk us through a few examples? Let's start with the method of sealing expansion joints. Now, just talk us through these examples from your guidance document. What are we looking for here, and what should designers be looking out for?
Well, I say this, but not facetiously, that it's there in the first place. And I say that because we've seen a number of instances in recent times where fire seals in compartment walls have literally not been there because they've either not been spec'd in or ultimately the specification has not been followed through. But one of the key things to look for here is the aspect of whether it's a solid wall, like a block wall or a brick wall, or whether it's a lightweight wall, like a plasterboard wall. Now, here the designer must be very conscious of the fact that the seal that he's using is appropriate for the particular type, because they don't mix and match.
So it's between the top of the wall and the underside of the...
Yes, this is to allow for the natural movement of a wall and ceiling configuration, to ensure that it doesn't open up, as I said earlier on, with the integrity being breached and allowing smoke or hot gases to penetrate through.
Moving on to the next one, what do we got here? Cable trays through large openings. Now, what again should designers be on the lookout for?
Here, there's an important point to make. Quite often cable trays may be put through at a later date, in which case they're put through and there's a large hole left. Now, you can't ask fire to be selective about when it's going to catch fire. So consequently, something that might be in maintenance process is a difficult issue. So quite often these kinds of configurations can be temporarily made good with a special intumescent bag or a vermiculite bag, which will actually seal that area on a temporary basis. But otherwise, the common system would be to use a mineral wool backed with an intumescent or subliming coating on it.
Moving on to the next one, pipe collars.
Pipe collars, well, here we have two types in essence. You've got the pipe wrap, which is the type that's put in usually when a building is being constructed, a wall is being constructed, and a pipe collar, which will go on afterwards. But the function of these is quite the same. They're a very powerful intumescent, a graphite intumescent, designed to shut down the hole that would be made by a plastic pipe, because clearly a plastic pipe is going to break up fairly quickly or melt in a fire. So consequently, you need to block that hole off to ensure hot gases don't penetrate. But the message here, again, is a simple one. There are lots of different generic types of piping, and you need to be clear that you've got the right pipe collar for the right plastic.
Here we've got a multi-cable array coming through a compartment floor. It's pretty neat, isn't it?
Well,
not like that in practice.
Yes, it is. Well, the drawing is, of course, yes. Generally, these are poured systems with a cementitious or a gypsum pour. But the crucial thing to point out here is twofold. One, they shouldn't be done in small layers because the lamination will weaken them. But the most important thing is that designer must be conscious of whether that area is ever going to be walked on. Because if it is going to be walked on, quite clearly reinforcing needs to be put into that system. So the designer needs to talk to the manufacturer to ensure he's getting the right specification.
The recent amendments recommend a door undercut of 10 millimetres or 20 millimetres if there's no carpet laid. Does this jeopardise compartmentation?
It is primarily domestic. Therefore, it doesn't have the same connotations that affecting Part B might have in terms of fire protection. However, it does prove an issue because an intumescent seal, when it expands, is likely to go to 10 millimetres, not 20 millimetres. So in practice, it wouldn't work, and in practice there is a compromise, and it's an example of where one part of regulation doesn't necessarily tie up with another.
Yes, because the undercut is there for ventilation in some instances, a flow of air.
Indeed. But as I say, it is primarily domestic, so in that sense it doesn't carry with it the same, same issues.
BS 9999 is the key to compartmentation, isn't it? But with sprinklered buildings or fire-engineered buildings, compartment sizes can be greater than those specified in the British Standard, can't they?
Well, I mean, BS 9999 is a variant, effectively, of the building regs, and it does give the designer opportunities to look at things in a slightly different way, in a more engineered way, which is excellent, really, because it is using the holistic approach of mixing passive fire protection measures with active systems like sprinklers. The important thing to bear in mind here, though, is that what is designed for the life of the building. So the designer has to be conscious of the fact that if he's using 9999 to push the parameters slightly from a fire engineering perspective, that things aren't going to happen later on in the life of that building that is going to compromise the design of what he's done, because that isn't acceptable.
OK. Let's have a look now at some of the materials. Now, there's a common perception that concrete is a fire-resistant material, but what happens to concrete in a fire?
Well, it explodes,
right?
Basically.
So it's not that great then.
I mean, fire officers will tell you that they're probably at greater risk from exploding concrete than they are actually for the fire themselves. That's because you have a lot of moisture in concrete. Effectively, you put a very hot temperature to it, you'll get a thermal shock effect and it will implode in effect. The Channel Tunnel is a good example. The lining of the Channel Tunnel started its life 200 millimetres thick, and after the first fire that they had down there, there was 20 millimetres left at the end of it. The rest of it had spoiled away.
Right. Well, you've got an interesting picture here showing us the comparative fire resistance between steel and timber. Talk us through that.
Well, people think of timber as something that burns, and yes, it does. And some of the recent fires we've seen in London and Glasgow would indicate that's very much the case. But so are fire doors made of timber. They have a very measurable rate of burn, and used in the right context, they're absolutely fine. The concern perhaps now is with modern methods of construction, we're looking at innovative ways of designing wood into I-section type structures, work very well from a structural loading standpoint, not so clever from a fire perspective. But put the two together and they can be quite comparable in the right circumstance.
Research has indicated, hasn't it, that openings in steel beams can actually reduce the critical temperature for their failure. Is that right? Yes,
cellular beams, generally, they're known. If you look around most cities now, they're quite commonplace. And from a designer's perspective, they're a wonderful development because they allow additional spans, they allow for penetrations that otherwise would have had to have gone below the steel beam to run effectively through the steel. The difficulty comes, of course, with the failure temperature in the context that the limiting temperatures may have to be a lot lower because the steel is by nature that much weaker. The ASFP, the Association for Specialist Fire Protection, is in the process of carrying out a number of industry trials at the moment looking at square holes, if that's a contradiction in terms, as well as round holes to ensure that the designer has complete freedom to model as he wants to model, with the appropriate fire rating.
BS 9999, Code of Practice for Fire Safety in the Design, Management and Use of Buildings, states that in practice, designs are often compromised due to incorrect or poor installation. substituted materials or products, missing materials or products, the lack of integration of active systems, inadequate inspection, lack of full commissioning, abuse during normal use of the building, inadequate maintenance and/or testing, and problems resulting from inadequate management documentation and training.
It seems like management systems would go a long way to resolving many of these items. So, Wilf, let's talk about Building Regulation 16B, part of Approved Document B. Now, this states that fire safety information must be given to the responsible person. Now, what sort of information do they need?
Well, that is a pretty damning list that we've just been given. I mean, and in essence, the whole purpose of 16B, which was introduced in 2006 as part of the revision to the Building Regulations Approved Document B, and in fact came from the Partners in Innovation project that I was speaking to earlier. The whole objective here was to bring together the issues and applications that take place on a site in terms of the fire performance, to be given as documentation to the responsible person, i.e. the owner of the building, to ensure that they have a clear understanding of what's gone on in their building, to enable them to do an appropriate risk assessment.
Yeah. The responsible person is further described in the Regulatory Reform Fire Safety Order 2005. So to start with first principles, can you remind us what the RRO is about?
Yeah, so the Regulatory Reform Fire Safety Order was introduced in October 2006 as part of a major change to the way reform takes place across a whole number of different issues. But the primary concern here is the difference between the way a building may be handed over. Historically, the fire service would produce a certificate and that would be passed over to the owner of the building as a completed and accepted building. From that date, it became the responsibility of the owner of the building, the responsible person in effect, to take charge of that issue and ensure that the building was in fact fit for purpose. Now, to do that, he is then required to carry out a risk assessment and maintain that risk assessment.
So 4 years on then, how far do you think that the building owner has grasped this role as the responsible person?
Well, I think that's a bit of a mixed issue. I would say perhaps as many as 1 in 4 haven't fully grasped the responsibilities that they're obliged to comply with here.
Where the Building Regulation 16B talks about the general duty of care, what are the implications of this, especially since a responsible person doesn't have to be a competent person?
Well, yes, this is where the word competent gets very confused. The responsible person will ensure that the building or an appropriate risk assessment is carried out by a competent person. Now, that could be from within his own organisation, but in all probability, he will bring in a competent person who specialises in doing this work. The difficulty for him is that there is no legislation or qualification to ensure that the competent person that he's bringing in is competent to carry out the competent work, if you're following me on this.
Yes, I think I'm with you.
So it is quite a difficult situation for the responsible person to ensure that he has the right people to do the job. And it's absolutely essential that he checks their credentials thoroughly and isn't tempted with an online version.
Yes. Your organisation, of course, has carried out a detailed long-term study on this. And what are the main issues, do you think, that designers and contractors and maintenance teams should be on the lookout in terms of fire safety?
Well, it's a process that starts with the birth of a concept and ends up with the life of the building, in effect. So it goes from the architect through the main contractor, through the specialist contractor who's installing the work, through to the owner of the building. And there are a lot of risks along that way. We have a regulatory system in this country and a set of standards that clearly lay down how things should work. The question and the difficulty is enforcement of ensuring that those things actually do work. The designer must be clear on his specification. He must ensure that the product will do what it actually says it will do. This is one industry where it says whatever it says on the tin is not necessarily appropriate. The main contractor must ensure that he, in turn, selects competent people to do the work through third-party certificated, through a third-party certificated approach. That way he's ensuring that the work that's carried out by the specialist is audited by an independent party.
Yeah.
The main contractor should ensure that all that information is passed through 16B to the responsible person. I find in many, many instances that doesn't happen. So here we have a system that's been put in place, but it's not being conformed to. Now the responsible person has to understand the obligations he's under. He has to understand that he must employ a competent person. He must have a risk assessment, but more importantly, he must maintain that risk assessment from the life of the building. Once any work is carried out on that building, and the biggest risk is the following trade. Who isn't a specialist? Could be a plumber, could be an electrician, could be a communications person. They're putting, as I said right at the beginning, they're putting holes in walls, and if they're not experienced and competent to understand that what they're doing is appropriate, then the fabric of the building has been compromised.
Yeah.
So it is a cradle-to-grave responsibility.
Yes, and ultimately this is a matter of life and death, isn't it?
It certainly is.
Yeah. Well, thanks very much, Will, for explaining the complexities
Thank you.
and some of the simple gains that can be made from this passive fire protection legislation and good practice. Bear in mind that the new Fire Safety Employees Capabilities England Regulations 2010, which is part of the Regulatory Reform Fire Safety Order, was released on the 6th of April 2010. This formalises the duty on employers, stating that staff must have sufficient training and experience or knowledge. So employers will now have to think about what a worker is able and unable to do when giving them tasks dealing with fire risks. This relates to those carrying out fire risk assessments and to nominated fire wardens or marshals. We'll include some detailed information from the Association for Specialist Fire Protection in the study notes and some additional reading for you to look into further. But from now, from all of us here in the studio, until next time, goodbye.